So if I have something like this, and I want to put this set of vectors in unit vector form, this is 5i. This is 4 by 3, that's 4i plus 3j. If this is an 8 by 6 right here, that's minus 8i plus 6j. This is negative 8 plus 6. And the last one going straight up would be 4j. If I sum all of them together, I would just be adding together all the I. Okay, so if I add A, B, C, and D together, it's 5i plus 4i minus 8i, which gives me 1i. And then I add together all the j's, 3j plus 6j plus 4j, which gives me 13j. Okay, that would be the sum of all of these. So all we're doing is the same old, but we're calling the xi and the yj. I think we'll just do one more, and then we're going to move on to vector multiplication. We're going to do 139. Kylie, can you please read 139?
Write each vector in figure 1.39 terms of the unit vectors I and j. B, use unit vectors to express vector c, where c equals 3.00a minus 4.00b. C, find magnitude and direction of c.
Okay, so it's the same old. You're going to get your components, but then once you get your components, instead of just writing them in parentheses, you're going to put them in terms of I and j. So let's get started on that. You should be able to move speedily along. Okay, now when we use 30, that's our reference angle, right? Now, when you do B, you're going to have to put your negatives in, right? Because you're in the third quadrant. Write it in unit vector form, so you're making the x1 an I and the y1 a j. So we're just going 3.6 cosine 70, 3.6 sine 70. And then what do we do with it? We put it in terms of I and j. So our vector A is equal to 1.23 meters I plus 3.38 meters j. It's just a matter of putting it in terms of I and j. Our vector B, so similarly, we went 2.4 cosine 30, but we had to put negatives in because it's in the third quadrant. 2.4 sine 30. So vector B is negative 2.08 meters I minus 1.20 meters J. Okay, we're just doing the same old, but instead of just putting them in parentheses or calling them AX and AY, BX and BY, we're putting them in terms of I and J. Okay, now 3A minus 4B. So you're going to get 3A, so multiply your A times 3, multiply your B times 4. You're going to subtract one from the other, and then you're just going to put that in terms of I and J. Show me if you have the insert to see. We're going 3 times A. Not sure if I saw that. Okay, and minus 4B. So C is 3A minus 4B. All you're doing is multiplying every A term by 3. And then every B term by 4 and subtracting one from the other. Okay, so we have 3A is going to be 3 times 1.23 I plus 3 times 3.38 J. You can either multiply B by 4 or by negative 4. If we multiply it by 4, we're subtracting. If we multiply it by negative 4, we're adding. I suggest you read the book. This is stuff where the whole physics 2 is like this. So then we're subtracting out 4 times. This thing stopped working. 4B. So 4 times minus 2.08. Four times minus 1.2. Okay, then you're subtracting one from the other. Or if you multiply the negative in, you're adding. Okay, you can either subtract a positive or add a negative, right? Show me if you have the answer. After that, you're just using polar form and okay, good. Now you should have. So remember, you just do the x with the x, the y with the y. So 3 times 1.23 minus 4 times 2.18. I'm sorry, this isn't writing very well, but you should be able to see. We're just doing the x with the x. So 3 times 1.23 minus 4 times 2.18 gives us 12.01i. Okay, we're just doing the x with the x, the y with the y. We do not do the x and the y together. 3 times 3.38 minus 4 times negative 1.2 gives us 14.94j. So instead of having this comma that, we just call it I and j. From there, you use Pythagorean theorem and arctan again. Same old, same old. We did the same exact thing we did before, but we're just calling the xi and the yj. Nothing has changed. Do you understand? Show me if you have your magnitude and angle. So you're using Pythagorean theorem and arctan. Kylie, do you have the magnitude? Good. We do Pythagorean theorem. We get 19.17 meters. Now we no longer use I and j for magnitude and angle, right? And the angle, do you have that? No. So they're both positive, right? So we're not adding 118. So you're just going arctan, 14.94 over 12.01. Do you have it, Alyssa? Good. All right, so that's it. What does this do? It just shows you, instead of putting things in terms of, AX, AY, or one number, comma, the other in parentheses, we're just using I and J. Nothing else has changed. So for homework, I'm giving you 30 through 38. Let's talk about vector multiplication. So again, unit vector is just another way of writing the same old, same old. There's nothing hard about it. Okay, we're going on to vector multiplication. Okay, so first we're going to start with the scalar product. There's two ways you can multiply vectors, the vector product and the scalar product. The scalar product is represented as A dot B. Okay, so there's two definitions for the scalar product. We're starting with the first one. The first one is the magnitude of A times the magnitude of B times the cosine of phi, where phi is the angle between the vectors. This absolute value sign just indicates that magnitude is the absolute value. So another way you can write magnitude is just like this. I usually just write it like that. The angle between A and B when placed tail to tail. Okay, so let's write that down here. A dot B is equal to, so the scalar product, I've talked about this already. When we multiply force times distance to get work, that's the scalar product. Remember how we got the x component? We went like this, we went like that. This was theta, this was our force. So we went F cosine theta times the displacement. Okay, and we got a scalar. It's called scalar product because you get a scalar. It's called dot product because it's represented by this dot. So you multiply a vector times a vector and you get another scalar. Okay. So again, the angle is between them. Another way of representing this dot product is A dot B equals this, which is the component of B in direction of A. The component of B along the direction of A. Remember how we talked about this is how when we were looking at force, we said it's a component of the force that's parallel to the displacement. It's the same thing here. Okay, so that's one definition. The scalar product can be positive, negative, or zero depending on the angle. Okay, the cosine of 90 is 0. Similarly, if you have a perpendicular force, you're not going to get any work out of that. It's best to have it applied parallel. If theta is between 90 and 180, it's negative. Okay, you have friction acting, that creates a negative work. As soon as you go in the other direction, it's opposing the motion and we get negative work. If theta is 90 degrees, is 0. Remember how we spoke about how perpendicular, if the normal force doesn't do any work, gravity doesn't do any work for something sitting on the ground. So if theta is 90 degrees, it does no work. It's the same idea, but this is now called scalar product. If we had had scalar product at that time, I would have talked about how work is the scalar product of force times distance, or else the dot product. Okay, now this is the equation we use when you have it in magnitude form, A dot B times the cosine of phi. What if they give it to you in component form? Then what do we do? Okay, so then we have a different equation. The two are equal. If you're given it in magnitude form, you would use the magnitude equation, and if you're given it in component form, you use the component equation. This is the component equation. AX BX plus AY BY plus AZ BZ. The scalar product of two vectors is the sum of the products of their respective components. Okay, so write that down. Then set those two equations equal to each other and isolate your cosine phi. So we have the other one, AX BX plus AY BY plus AZ BZ. These two equations are equal to each other. A dot B cosine phi is equal to AX BX plus AY BY plus AZ BZ. Just depends on what you're given, which one you use. Okay, finding an angle using the scalar product. Let's say we have a 3D vector and a 3D vector, and we want to know what's the angle between them. So these vectors A and B, how would we do it? Okay, so that's where we're going to use our two equations of dot product. Really didn't really show it. Oh gosh. Okay, so we have our two equations. We set them equal to each other. And then we isolate our cosine phi. It's a little bit better to see here. So now I have this isolated, but what if I want to get the angle, right? I have to use our cosine. So I can pull out this angle by using arc cosine. I have it right here. Theta is equal to arc cosine all of this. Okay, so you're going to be using that equation. I don't really have any places to write it down. Let me write it down up here. This is between two 3D angles. We don't really have to go through all of this if we have 2D angles, but we can if we want. Okay. Let's start by doing some simple scalar product, okay? Now, you're told you have two vectors here. A is 5 and B is 3. And the angle between them is 53.13. I want you to use both definitions to get the scalar product, right? You should get the same thing every time. So first, the magnitude of A times the magnitude of B times the cosine of phi. Let's see you do that. So all you're going is 5 times 3 times the cosine of 53.13. Okay, that tells you the multiplication of these two vectors. Now, to use the other one, you're going to have to get your components. Dakota, did you get this one?
I got 9.
Okay, good. We get 9. Okay, now you have to get your components. We're going to use the other definition, ax times bx plus ay times by. So we're going to go 5 cosine 53, 5.13, 5 sine 53.13. And get those components. You already have the components of this, right? Because it's horizontal. y times y. Okay, so we then get our components. So you get 3, 5 cosine 53 is 3, 5 sine 53.3 is 4. Okay, so we have the ax times the bx. For this horizontal one, right, your x is 3, your y is 0. So we have 3 times 3 plus 4 times 0. In each case, we get 9. So all we were doing is setting this long one, ax, bx plus ay, by plus ac, bc, is if you have 3 dimensions. If you have 2 dimensions, all you have is the ax, bx plus ay, by, right? And then we have the magnitude of a times the magnitude of b is the cosine of phi. So first we did this, and then we did this. And you should get the same answer each time. Do you understand? Because those are equal equations. So we got our components, we multiplied them together, and what we have is a scalar. So we don't have an answer in terms of I and j, right? Because we're not working with a vector. Okay, let's do another one. I want you to do the same thing. First, you do the definition of just the magnitude of a times the magnitude of b times the cosine of phi. So this one is 6, this one's 9. Then you get your components and you multiply the components together and add them. Okay, so you're going 9 times 6. What's the angle between them? What's phi?
3 degrees.
What?
30.
3?
30.
Okay, this is 170 and this is 50. So the angle between them is 120. 170 minus 50. So we're going 9 times 6 times the cosine of 120. Then you're getting your components, 6 cosine 50, 6 sine 50. So we should get the same exact thing when you plug it into AX BX plus AY BY. Nevaeh, what did you get for the first one? Okay, good. And then did you get your components? We should have this.
Yes, that's right.
Okay, so we get 6 cosine 50, which is 3.86, 6 sine 50, 4.59. 9 cosine 170 should be minus 8.9. 9 sine 170 should be 1.56. Then you're multiplying the AX and the BX, the AY and the BY, and adding them together. Okay, so it's not going to come out exactly the same because we're rounding. But when you multiply the x times the bx, you have 3.86 times minus 8.9 plus 4.59 times 1.56. So if I tell you a force is 3I plus 7J, and the displacement is 2I minus 10J, tell me what the work is. So when you multiply this out, you should get about minus 27.2. It's approximately the same answer. Now, if we didn't do any rounding, that we would have gotten the exact answer. Okay, so what's the idea? There are two ways for this scalar product. The first is the magnitude of A times the magnitude of B times the cosine of phi. The other one is just your AX, BX plus AY, BY. So if you have a 2D vector, you can just get it either way. Now, I asked you what the work was. Maddox, what's the work? How do we get the work? Anybody? Right, so how would we do that? Three times what? Right, 3 times 2 plus 7 times minus 10 joules. Okay? We're just going AX times BX plus AY times BY. Now, if I said the force is 10 newtons and the displacement, this angle is, we'll say 60 degrees. Then you'd use the other technique to get the work. So let's say this goes 20 meters, okay? To get the work, we can use magnitude and angle. The force, 10 newtons, times the displacement, 20 meters, times the cosine of 60. Okay, that would give us 15 joules. So when we were getting work, what we were doing was scalar products. We didn't use this one because you didn't have that equation yet. I'm only, okay, I didn't really get very far. So I think that we'll just stick with what we had for homework, and then I'm going to ask you to read the chapter. I mean, especially for those of you who didn't have a good math or science background, right? This is just might seem overwhelming to you. And reading the chapter, it helps a great deal. It also helps your reading skills.